So welcome everyone to this week's FinML meetup. I'm very excited to have two guests here. So Laszlo from Hypergolic is joining us to talk with us about testing of ML models, like the different approaches, as well as Neal from Monzo is also joining to talk about the same topic. So this meetup will be again slightly different in the sense that we'll have some questions prepared, and the three of us will just discuss our views on these various topics. So the first 30 minutes are this discussion that we have between the three of us, and then we open up to the floor as well. So if any of you have any questions that you want to raise, please put it in the chat, and we are picking it up from there. With that being said, I will share a screen to give a very brief introduction. So yeah, the first thing I wanted to talk about is classical software development, right? So how does testing work in a traditional software development meetup? In a classical software development process. So you would have some kind of code repository. You would create like some kind of feature branch on it, make some code changes, write some kind of tests on it. Maybe in this way, maybe you write the tests first. Then you would run the tests, and then there's some kind of like PR process on getting these things approved. And within classical software development, the typical tests are unit tests. So this is really like, is there a particular like piece of code, a block of code that's running as expected, usually by testing inputs and outputs. Regression tests, so with like more complex behavior, typically issues that occurred in the past, trying to test these, and then integration tests, again, more complex workflows on how different components are interacting on these together. Laszlo, Neal, any comments on this particular one? Anything you want to add to this end?
Maybe just one thing that recently feature flags came up as a part of the merging solution, which kind of probably going to be relevant later when we discuss models, because they decouple merging and actual usage or visibility. If you think about shadow deployment, you know, that can be relevant.
Mm-hmm. So feature flags, just so that everyone is aware, would be a configuration within an application that would actually allow you to show a particular feature or not, right?
Yeah, exactly.
Cool. So then if we compare that to a very, very basic machine learning workflow, so we have a new idea or some kind of models being detected. We would then again have some kind of branch, would modify code to build artifacts, train a model, calculate some kind of evaluation metrics on some kind of like testing data set, maybe do cross-validation. And ideally, there's some kind of review process on top of that as well before things get released to production. So the very first question is, so there is at this stage, before we go into more complex details, there's already this calculate evaluation metrics. Maybe Neal, do you want to start with like what kind of guarantees do we get from this testing evaluation step? And what does it not provide? What do we need to test in different ways?
Sure. I was recently going through this journey with an engineer who had never done machine learning before. And he went through both of these slides, both of these processes, and wrote unit tests for the code that he wrote, and so on, and then proceeded to train a model. In this case, he was fine-tuning BERT for a particular classification task. And his comment to me was, back when I was just doing classical software engineering, I'd be able to go home at the end of the day feeling confident that the code I wrote works. And now I don't know. So I guess that's the key difference with machine learning, is that your code can work in the sense that it can execute, it can produce a result, but the uncertainty comes into whether that result is actually any good. So that's where we enter, I guess, this first stage of offline testing, where you're looking at your this blue dot that you have here on calculating evaluation metrics, whereby we're not anymore looking at whether the code is functional, but we're looking at whether the model that has been trained appears, according to our historical data, to show promise. And I use the word promise because of two things. One is that we need to pick some evaluation metrics. What does it mean to evaluate a classifier on some historical data? And that choice may be wrong. And two, even when we pick the right metrics and we proceed with adding the trained model into production, the evaluation metrics may not correspond with what we actually see when the model is live. So I think that blue dot is where things deviate, and where we can basically use all of the same approaches that we use in traditional software engineering, but now we need to factor in new testing strategies because we're dealing with such uncertainty.
Mm-hmm. Laszlo, do you want to add anything in this?
Yes, usually the way I used to think about it is some of the guarantees or promises what you can get from a machine learning model is statistical. So if you think about one of the reasons why you can have continuous integration in software engineering is because if a test fails, then it will gonna always fail, or at least you would expect that to happen. But in machine learning, you, by definition, every evaluation metrics is just a statistics, you know. Sometimes it fails, sometimes it doesn't. And I think this is where you can draw a quite good border between software engineering and machine learning. Is if you have this kind of instant reactions, then it's software engineering. If you have some kind of statistical reaction, then it is it's machine learning. So it is a special to, and the analogies are kind of stopping.
Mm-hmm. That makes a lot of sense to me. So in a way, you were saying that machine learning, the artifacts are not only defined by the code that is being written, but there's also another component. So I guess in this specific case, data that might change the output of any particular code that you write, right? Besides like calculating kind of overall performance metrics on models, is there any kind of other testing that you would need to apply for machine learning models? Maybe Laszlo, do you want to start, and then Neal can go after?
I see Neal nodding, so I would pass on the baton to him. And
okay.
Yeah, sure. I guess the main thing you'll hear me say, or my team will hear me say often here, is that the act of creating a data set is something that should be treated nearly as a product in and of itself, which means that the thing that you're going to feed into the machine learning model should have been constructed in a way that you can test that you made it right. And there is a certain statistical element of that, but there's also a ton of the equivalent of unit tests, but for data. So this column should never be null. These columns should be in given values. These categories, we expect only 5 of them, not 15, and so on. And a lot of those things, if not tested for explicitly, can just slip into your data sets, and then you train on some garbage and you're wondering, why is my model so crap? And so in general, at Monzo at least, we like to split those two tasks up as separate tasks. Generate a robust data set to train a model, and then you can swap in and out any model that you like on top of that data set, feeling confident that the data set is not garbage.
Mm-hmm. That's maybe a great transition to the next slide, which is like different testing pyramid that I found on like the different parts of a machine learning pipeline. and the various tests that can be applied to various steps. So you already mentioned data validation steps. So the basic idea is we have a data pipeline, we have a machine learning pipeline, and then we have like some kind of application layer to make sure the model is actually being used and being served. And all of these different parts actually have different tests associated to it. You already briefly spoke about the data validation tests, so making sure that there are non-null values, for example, and that the ranges are similar and so on. And maybe if we go through unit tests, I think are reasonably clear here in the sense that they refer to the transformations. For the machine learning pipeline, do you feel like unit tests are generally a good way to apply there? Is there any other testing that could be done? Well, like maybe Laszlo, do you want to take it here?
Yes, but I also have a comment on the previous question. I think it's important what Neal was referring to that, but when you are creating a data set, then you have some kind of assumption that the distribution of the data set is describing somehow the real world. And I think often as a cliche, this is used as, you know, training environment and real world environment is completely different. And there is like no relationship between them, but that's not true. That is some kind of simplification of, or lack of agency, determining of, yes, it's the data scientist's job to create a data set that is representative of the real world. And these assumptions need to be checked, whether they are still relevant. So at least the transformation or the prediction step, which is essentially another distribution estimation, can be performed correctly. And I think this is part of data validation. You know, it's not just nulls. It is also, am I having the same mean as, am I having the same rare events in my training set as happen in real world, which can be a very relevant downstream. Okay, so now.
Okay,
does it make sense?
It does make sense. I'm just wondering on like where you put that, right? So for me, that's so really what you're saying is there like some kind of like training and serving skew, right? So is the way that your model is being served different to the way that your training data is being generated? Yeah,
if you have that problem, that needs to be addressed. You're not supposed to train your model in the data that is completely different than what you have in real world. Like you would start investigating of why do you have and can you do something about that? Because that is a low-hanging fruit in terms of like how do you handle it. I mean, we can. I'm not sure where are we going, but you know, we can talk about it later. But I would think that getting back to the question of how do you test ML pipelines, it's important to make sure that you are testing the right thing. So you're not supposed to test the pipelines themselves. You know, if that's a package, you know, that has its own tests, you know, that's fine. But you know, I think most of the gist of the transformations are the engineered features. You know, the transformations, the unit tests which are on data or on the model.
Mm-hmm. Yeah, I think that's a very good call out to not overinvest in unit tests on the narrow pipeline. Neal, is there anything you would want to add there?
Yeah, I have 4 testing ML pipelines in particular. One of the things that we do is use public data sets in our ML pipelines and check what results they receive. So very simple example, you're going to train a text classifier. There are many public data sets for text classification where the results of training that type of classifier have also been published. And this is a really good way to check that your pipeline doesn't have sort of tiny bugs in it that are going to completely skew the results. And it gives us, again, all of these testing strategies, what they're surmounting to do is give you confidence that the system works. And so when we had our pipeline for creating text data sets, then we wanted to be able to look at those, validate them, make sure we've dealt with edge cases, and then moving on to that middle tier, without injecting our own company data into the pipeline, we just put one of the squad data sets into it and see that the accuracy that gets spit out at the end of the process is broadly what we expect it to be. This gave us confidence that the ML pipeline is implementing a training loop in the way that we expect it and replicated by other researchers. So we had some unit tests there, but to be honest, they were testing very simple things, simple transformations and those sort of very small things. Whereas the most confidence that we got in our ML pipeline was by training it on a public data set and seeing what numbers it spits out.
Mm. So you can validate the ML pipeline by changing the incoming data pipeline in a way.
Mm-hmm. Yeah, I guess it becomes a bit trickier if you're going to be training something very specific in terms of a model that doesn't have the equivalent in the public or research domain. But what we for all of our tech stuff, there are those equivalents. I guess the other thing that gives us a lot of confidence is being able to reuse training pipelines across several problems. And therefore, so for example, like we want to train a transaction classifier against a specific type of fraud. And then we use the same pipeline to train a different fraud classifier just on a differently shaped input data set. So we know that what has worked before is going to broadly work again. So minimizing how many times we have to rewrite the same or similarly behaving pipeline is a way to minimize the chances for us to make mistakes, or at least looking at it from the other lens, the more people we have looking and using the same pipelines, the more chances we have for them to discover any mistakes in them and then fix it for everyone.
What do you exactly test in these two cases?
So for the first case, we were just, for our BERT fine-tuning pipeline, we're effectively just trying to make sure that it can replicate the results on the squad data set. And so we're training models on squad and looking at the accuracy results and making sure that they align with the public benchmarks. For the second case, I suppose you can imagine all sorts of very small things that come into a tabular training pipeline that could cause some issues, maybe in how you're sampling, maybe you do your train test split in a weird way or something like that. And so in this case, having multiple people use the same pipeline, again, it falls outside of the strict definition of a test, but in terms of giving us ultimately confidence that the pipeline is doing what we think it does, it achieves that.
Yeah, because in my view, this is more like a model performance test or even an integration test where you are expecting failure modes which are other than unit tests. So let's say a division by zero or a null pointer exception, is something around that, takes down the pipeline. That's what you expect from an ML pipeline test, but not from performance model performance test.
I can move us on to that third column there. There's an interesting journey between the second and the third, in that now we have a trained model and we want to do some tests around ultimately getting this model into production. And so I see it as like one pyramid that's drawn here of like testing the UI, testing the inference microservice and all the unit tests there. But we usually have a step in between, which is manual testing and doing error analysis on the model itself. So again, if we take a text example, text classifier example, we built a small CLI tool that then everybody in the company could throw whatever words they wanted at this thing and see what it was going to spit back. And we would then put these models into shadow mode where they're making predictions and maybe just off the back of their predictions, creating a Slack post saying, you know, the model has predicted X, and we would be able to validate it. So again, a lot of these tests are geared towards the behavior of the model, and they have the same foundation of unit tests. But right now, our unit tests for the inference side are all templated, and no one's actually writing them. Their core functionality is more to catch people breaking stuff in our template rather than forcing people to write extra unit tests.
Anything you want to add to that, Laszlo?
Yeah, it's obviously different companies have different resources, and the use case is very important as well. So, for example, we dealt with natural language processing, so like raw text, and it's kind of like, for us, the best solution was to use the ML pipelines as large scale as possible, and have as much data as possible, like millions of documents on every test, because we were expecting that you will going to run into enough edge cases that if there is something happens, that it's going to take down the pipeline there. And it was always it find more interesting failure mode than we can come up with intuitively. So my favorite example was we failed to translate a Russian text, and the entire text was one token. And no one thought when we were writing the TensorFlow models that there's going to be a word with 5,000 tokens or characters, and that took down the pipeline. So these kind of things, like, I don't think we are going to have enough time to come up with a unit test for this. But you know, if you have a million article, you're going to have all kind of different content. And that's, but yeah, like I think Neal nailed it with his CLI idea.
Well, there's one follow-on from there. So you mentioned having this corpus of 1 million documents. In one of our ranking systems, we have a similar assumption, which is that we're going to be ranking the help articles in our system, and we expect that there are going to be in the order of a few hundred articles to rank. And so we can encode that as, and it's not quite an integration test because it doesn't happen before code gets deployed, but more like a monitoring flavor of test, that we're querying this system that is live in production and asking it, how many articles do you have to index in your index? And if it replies saying, you know, I have 1,000 or however many we expect, then everything's good. If it replies saying, oh, I've got 5 articles in my index, then we know that something has gone wrong in how the data is flowing through that system. And so we have a bunch of these types of tests. A very specific instance of that is if a customer searches for fraud in the Monzo app and says, you know, reporting fraud, and they search for that on the help screen, we really need the how to report fraud article to be returned. And this is something that could maybe get lost in evaluation metrics when you're averaging across thousands of help articles. And so we have encoded those as like test cases that our production system is regularly queried with. So we will regularly hit our production search system with an automated cron job saying, give me the search results for reporting fraud. And we check that the top 3 results have that expected result in them. So that experience comes from the fact that there were several times where other teams, product managers, so forth, would come to us saying, uh-oh, the machine learning model is broken. And it would set off a mad panic on our side of like trying to diagnose where the machine learning model had broken because it's not returning certain search results. And 9 times out of 10, it was because the upstream system, which was pulling all of this content out of our CMS, had somehow failed. And every time we were mad panic, uh-oh, the machine learning model, something in the training, something the data set, our offline metrics. And that sort of panic is something that is really hard to deal with when you've got other teams bearing down on you saying, you know, these search results aren't showing up and they really need to critically show up. That is what led us towards automating these sort of tests. And I know that I'm sort of now, again, I'm drawing a thin line between testing and monitoring, but we think of these as like test cases that our live system must comply with at all time.
Yeah, that was such a classic, because you have this experience that because machine learning is treated like a black box, and like a magical black box, if anything is broken, it must be that, you know. And then you get all kind of weird requests from lagging issues, from any kind of typos and anything. It must be the machine learning model. It must be, you know, those weird guys are doing something in the basement and
yeah,
they broke something again. But no, it's not.
Yeah, it's a really good point. There were a couple of questions already in the chat, given that we are now starting to come to the halfway mark. First, Rosanna asked, where will the recordings be posted after? So you will receive an email for the recordings as well. And then Patrick asked, what non-functional tests fit into the pyramid? Any thoughts on this, Laszlo? Yeah.
What is a non-functional test?
I guess Patrick would need to answer. Personally, I guess it's something around latency requirements, for example, or something around like error rates. Security is what you mentioned, load testing security, yeah.
Yeah, good point. There is like an ongoing argument or conversation about this on the MLOps community, because this is like somehow between DevOps and MLOps. It's not even machine learning, because I don't think that the speed of reaction speed is not really a machine learning problem. The machine learning problems are statistical in nature, you know, F1 score and stuff like that. And I think this needs to be separated into DevOps problems, because it's better if every problem has its own, you know, responsible person, and you know that if the model doesn't reply in time, then this must be a DevOps problem. You know, maybe you need further instances of your model. If it's biased, you know, maybe it's an MLOps problem. But if it's performance is breaking down, then that's a machine learning problem, and you need to send the ticket to the right person. Otherwise, you know, multiple people will be responsible for the same thing at the same time.
One of the things that can give some confidence to both teams here is this concept of making shadow mode deployments and giving your machine learning models the full weight of production traffic without doing anything with it or with the responses from the machine learning model. So there's two ways that takes shape at Monzo now. For larger neural networks, we will have one microservice per neural network. And so we can split traffic and also shadow traffic to different services. And to echo Laszlo, yeah, I haven't really run into any problems there with like response times and stuff like that. That hasn't been solved by just throwing some more scale at the problem. Then for smaller machine learning models, random forest, gradient boosted trees, things like that, we'll often have several machine learning models within the same microservice. And then we'll be able to measure the latency of like getting predictions from 2 models instead of 1, or 3 models instead of 2. And usually, if you just take it into the super big picture, these services look slow. If you ask a typical Monzo engineer to look at our dashboard, they'll be like, oh my God, everything is so slow. And it's just because non-machine learning services have like a couple millisecond response time. And then we're looking at like 50 milliseconds for a prediction. And they're like, wow, that is super slow. but you need to teach them about what normal looks like. And one way to build up that confidence is through these shadow mode deployments, where you have a machine learning model, it's integrated with the system, it's receiving live traffic, those predictions are just being logged for later analysis. And so the other teams, the partnering teams, client teams or DevOps teams get to become more familiar with what it looks like when you're running an ML system.
Yeah, this is why I mentioned feature flags. Thanks for this example, because that's the analogy of like a shadow mode deployment is a feature flag for you, because you can pretend it's in production, but you don't cause business risk, and then you can just decide when to switch around and have the new one in production.
It's a great example. Given that there are no more questions in the chat, so please feel free to raise additional questions as well. Shall we maybe briefly go back to the Pernet and talk about model bias and fairness? So I hear there's a lot of concerns in like the regulatory space around these concepts. And this one of you, Neal, again, you're starting to not talk a bit about like what is this to begin with, and how do you actually go about testing these things?
Yeah, I suppose it's worth knowing that now there are entire fields of research dedicated to machine learning fairness and detecting, measuring, quantifying bias. And the literature there is growing quite rapidly, and it's really interesting. So I don't think I'm going to do it justice in a quick answer. As a director of machine learning, this is something that the way I try and frame it in a slightly pragmatic way for my team is it comes on two fronts. One front is what problems are we deciding to solve with machine learning at all? And is this something that is going to sort of dig us into a deep hole of trouble if we use machine learning for this? And so that's something that already there are certain problems that we know that you just shouldn't use machine learning for. And I guess the popular examples could be things like deciding what somebody's sentence should be when they go to court. If you just treat that as an AI problem, it's going to be trouble. And so that's one side. And clearly, in terms of the product at Monzo, we don't have too many problems that we have to say no to, but it's something that we're aware of. The other side of it is in terms of when you build a live system and you want to make sure that it's working fairly, a couple things jump to mind. One is with one of the image classification systems that we built, it's trying to detect poor quality images that customers upload into our system. And so things like the documents being out of frame or blurry and things like that. And one of the things that we knew ahead of time is image classifiers and their bias is tricky to measure. So let's just put a lot of safety controls into the system to prevent customers getting stuck in loops of false positives. And so we treat this as like a system design problem of like trying to mitigate the worst things that could happen to customers. And yeah, last note in terms of the bias stuff, I would definitely recommend reading up on the recent literature for language model bias in particular. It's really, really interesting. A lot of this stuff becomes even harder in a company setting because the data sets that we are dealing with are coming from people actually typing words into a phone and not crawled from the internet, where they may even be a bit cleaner than someone typing words into a phone. So we've run into all sorts of quirks in our data where even words that are written well, spelled well, and just mean completely different things classical example I always fall back on is customers writing to us and asking for, saying they need a visa, and the first time we saw that, we're like, that's really weird because we don't offer Visa cards, we offer MasterCard cards. But the customer was actually asking for a visa because they're traveling abroad, and they needed to ask for a visa, and therefore they needed a bank statement and all this weird stuff. So yeah, very, very difficult. The main thing that we do is ensure that we have these escape hatches in our systems, such that where our models are prone to making mistakes, we either can quickly connect customers to our customer support, or ensure that they're not going to get stuck in a loop of rejections or negative outcomes. So that's something that we need to balance at an operational level. Obviously, the main benefits of ML is automating stuff, but if you're automating stuff to the detriment of your customers, then you're going to ultimately lose out. Yeah, that's my mini pitch on this. With Laszlo, what do you think?
I think at the end, we processed a lot of text which was written by journalists. So luckily that's less of a problem. I do think that model bias and fairness issues are feasibility issues. So it means that you can't push your business problem through this entire pipeline and then check fairness at the end, because then you pit the business people against either regulatory people or you need to make a moral decision on the basis of money. I do think that you need to have these checks in advance, and use constraint optimization. I used to work in finance, and your model needs to perform inside some kind of risk constraints, and you just create models that are inside these boundaries. That can be a solution for that. But you're not supposed to create a model and decide later that it's actually biased. Maybe in fraud questions, you can make these things. In NLP it's harder, but I do think that models on tabular data, like any kind of loan-related data, location-based data, fraud detection data, that's much more prone to this kind of hidden biases. But also you are lucky that, probably easier to detect that rather than, some kind of gender-related issue in an NLP model, which is, very hard to do anything about that.
Cool. We have a couple of more questions. How do you ensure that they, what about ML models? How do you ensure that they perform as expected after sending them to production? And what if they don't perform as expected? So I guess that comes down to the whole monitoring debate. And thus, I don't know, Laszlo, do you want to go first? And then, yeah.
So we are advocates of lean ML or iterative machine learning, and this kind of process that the machine learning model is never really ready, because you're supposed to be in production all the time. And as Neal said, if you have problems with it, have an escape hatch, send it to a person and he can deal with it. You're not supposed to attempt doing anything which is not possible to do with a human. And that's how we dealt with this. So if there are like edge cases, the users will gonna detect them. We can flag these in the model and send them to humans, and then they're going to label it or send it to the clients as required. So that was our solution. Essentially, for us, evaluation, monitoring, and labeling is mashed together into like one step, where if you see something wrong, you flag those up with some anomaly detection and then send it to labeling, who they can assess how big deal this is and then inform the data science team to create a feature to specifically deal with this problem. This happens a lot with like industrial scale natural language processing, because there is like an extreme amount of edge cases. So most of your time you are chasing 0.1% problems, but you have dozens of those.
Yeah, I'll add some bits to that in terms of for a model to not perform as expected. It breaks down into two big areas for me. And one of them is actually a very positive sign, where if you have the ability to iterate quickly and get models into production and then go, oh, actually, this doesn't have the business outcomes that I hoped it would have. Let's try the next one. That's actually great. Like that's the sort of behaviors that I encourage in my team, that getting to a negative outcome, like, oh, I trained this model and then I put it into production and it doesn't do as well as I hoped it would, for whatever reason, then speeding up that cycle is something to be applauded and encouraged. On the other side, in terms of models that don't perform as expected because of surprising reasons, so things like, oh, this model was actually really overfit, or oh, the data we're seeing in production is actually very, very different from the data we were using to train the model, or this model has been in production for a year and a global pandemic hit. So all of those are kind of more unknown circumstances and require a little bit more attention to detail. Particularly the one around shipping a model that is overfit, or shipping a model that has these vastly different assumptions than what it's going to see in production, are ones where we'll sit down and have a retro and think, how can we avoid doing that one again? So there's been a couple of times where we have shipped models and they haven't had the impact that we hoped they would have, and that's been totally fine because we've managed to ship the model and test it, and it just didn't have the business impact that we hoped it would have. And keeping that up, let's do it again. Let's learn from that, why it didn't work as expected is actually really good. And then there's been a couple of instances where we shipped a model, particularly when we're trying to detect really, really, really rare types of fraud. And they're so extremely rare, but then they're going to be hit with so many millions of predictions every week that the false positive rate was way above our comfort threshold. And a lot of that has to do with building the system around the machine learning system. So getting rid of the obvious negatives with rules, making sure that you have a careful design around what data or what transactions should be eligible for this model, and thinking more broadly than just tweaking the model even more.
Yeah, great points. I think you started walking towards what we think of as ensemble modeling, where often data scientists think that the only thing what you can ship is a logistic regression or a random forest. But in practice, what you, as you said, you build a product. And this product can be as complicated as possible. That's one of the reasons why we are advocating using TensorFlow for every model, because then you can say, okay, I implement any kind of, this kind of system level details inside the TensorFlow model, and I ship it together with all my trainable components into, a standard service that can accommodate any kind of models. Engineering doesn't need to know that, I just changed the threshold in a deterministic rule inside the model.
Sweet, so we found something we disagree with. Finally. So yeah, my team uses PyTorch. And oftentimes I get them to write the rules in Go, because Go is the language that our backend engineers use. And I encourage them to write as much as possible in the language that our other backend engineers can read and understand, because then those backend engineers can edit it, maintain it, and stuff like that. So sort of extricating as much as possible from the ML box, if you know what I mean.
So your data scientists have permission to write production code. Okay,
Yeah,
so
yeah.
like that's an organizational question, because that's not trivial that you are allowed to create code, because then you write the unit test, then you should be a qualified programmer, but that's not standard for other places, while you can be responsible for the model binary. These are, that's a perfectly reasonable solution if you are allowed to check in into the production. And another point, what you mentioned about COVID hit, that's why you should think of your models as products, and there should be a product team who owns that model and any kind of performance around that. And I learned that in finance or quant finance, where you are not supposed to suffer from an event like COVID. The team who owns that model should anticipate effects and then prepare for it in advance. And then when it actually impacts the model performance, they can react to it relatively quickly. And that's an important mindset, because it means that you own that model. You're not supposed to just check it into some kind of system and then let the anomaly detection tells you where you need to check it again. That's never happening. It is always in a flux state, and errors can happen at any time.
Patrick had another question. How do you monitor, test, and etc. an ensemble model, and how difficult and does difficulty scale with the size of the ensemble, or scale linearly is this question?
Probably this is for me, but we're having these TensorFlow models, and they are tested through a large computational pipeline on those 1 billion article. And because they are ensembles, and every time you are only adding one feature, you can have a regression test and compare it to the previous run without the feature, and then assess the effect of this additional component. And that's a very important point, because often machine learning processes like CRISP-DM and stuff like that is represented as a circle. But if you retrain the model every circle, and that's completely different than the previous one, then what exactly your incrementalness are? That's a very important part of continuous integration, that you're always making only a small change. How do you ensure that your entire machine learning pipeline only changes a very little between two changes? And I think that's a very important thought. What's missing from like this kind of new age incremental machine learning is you need to be incremental, and I think that's Snorkel is one of the companies that are advocating these this concept, just like me.
Neal, do you want to add something to that? You started nodding.
Yeah, I guess the only thing I'll add is a lot of this. You can think of it from your analytics perspective, and how far can you zoom in with your analytics, and how far can you zoom out. And so if you have a system that may have some rules, may have some machine learning models, maybe retrieving predictions from several models and then putting them together, then does your logging reflect that, such that on a specific outcome basis, you can say this outcome was generated by this combination of rules and this model. And in so doing, you can then start to slice and dice the system in your analytics and say which bits of this are working well, which bits of this are working less well. That's kind of the big pitch for a lot of the monitoring stuff is we use our same BI dashboarding tools for our machine learning monitoring, because we want to be able to give a product manager that completely zoomed out view of the system. and they can just see how well is it performing overall in the given business metrics. And then a data scientist could zoom all the way in and look at, okay, if we remove all of the things that didn't touch the machine learning model and so on, then how is this doing on this these specific metrics? So yeah, a lot of this complexity needs to be tackled by enabling in your analytics to be able to tear apart the puzzle a little bit.
Yeah, this is such a good point. It's essentially model monitoring is business intelligence, isn't it? So essentially, I remember doing the exact same steps at King to analyze mobile games from A/B tests. You write SQL queries and you just interrogate until it throws out an insight what you can run with. What's important is to make sure that you are maintaining a chain of evidence, especially historically, because engineering, especially in logs, often doesn't take care that the entire history of the company's state is recorded. And I think data scientists need to actively go out and make sure that this is solved. This has been better since the ELT. So since you're load first, so it means that you have a raw state of the company every time you have a checkpoint. Rather than transform, because obviously if you have a transform, you can't go back and get the state of a specific enumerated type 6 months ago. If it's gone and you are unable to perform an analysis that far back in the past.
Mm-hmm. Very much agree with that. Are there any more questions in the chat coming up? Yeah, doesn't look good, right? Laszlo, Neal, anything else that you want to mention on the testing front?
Yeah, I'll say a few things. I think this is a pretty huge pyramid, and if I were to take all of our ML systems and do an assessment against this pyramid, they wouldn't all hit every single box. So I think with these concepts of testing and monitoring, it's easy to get overwhelmed. And so I think it's one of the key inputs when you're deciding how much to test something is basically how dangerous is this system and how risky is it if it goes wrong, and how much confidence do I need in order for me to feel confident that it works well. So as an example, we have an NLP system that gives our agents recommendations for these saved responses in our CMS on how to reply to customers. So it's basically a text ranking task as well. And the worst that could happen is that this system gives bad recommendations to the agents, and they look at it and they go, well, that's junk, and they don't use it. And maybe that slows them down a few seconds. Maybe they come to our channel and say, why is the system so wonky? But the risk is broadly quite low. And so in these cases, working quickly, iterating quickly are like the highest priority things for my team. And then you go all the way to the other end of the extreme where you're looking more at fraud and decisioning systems. And there it goes to the complete opposite extreme where every time a prediction is made by the system, we also capture like the Git hash of the code. Because we want absolute certainty that we'll be able to go back in time and say, at this time, this prediction was made by this version of the code, that model, this rule set, and these inputs. And so we kind of need absolute certainty on being able to reconstruct it if needed, being able to reconcile it between training and testing and inference. And those are for the most critical use cases, and where looking at this sort of pyramid, we would looking to be ticking every single box. So I think that's one thing, is that not all ML systems are equal.
Laszlo, any additional thoughts on this?
Yeah, the capturing the commit hash was default in our companies, and it's an extremely useful habit of knowing exactly what was the code that was training the model that was creating that prediction. The most important for us was definitely large-scale evaluation, which was like the main workhorse that surpassed everything. And we had unit tested our ML pipelining, these kind of low-level systems, just to make sure that they are engineering problems. So we said that, you know, those needs to be tested, and if we made some small changes, then they are going to be resistant against that.
Mm-hmm.
Thanks.
Yeah. To Neal's point as well, we are trying to distinguish it according to two ideas. So one of them is the cost of a bad prediction in some sense, so similar to the fraud case. And the other one is also we try to distinguish by feedback cycle. So specifically in the fraud credit world, you see that a lot of the time it takes really long in order to assess whether the performance metric actually dropped or not. And in those cases, you also need to be more diligent putting something into production, because you might run longer in production without knowing that it doesn't work.
Imagine waiting for 2 weeks and then realizing there was a bug.
Yeah,
A waste of 2 weeks. Yeah.
Are there any other questions in the chat? Because we are also at 7 now, so we are past the hour. Okay, so then I want to give a really big shout out to both of you. I really enjoyed the discussions. I think we discussed a lot of very interesting concepts. And I definitely learned a couple of things as well. So thanks a lot, both of you. Really enjoyed the session.
Thank you. Thanks to everyone who came.
Yeah, and also thanks everyone who attended for showing up, really helping us to make this a reality.
Thank you very much, guys.
Thank you. Bye.
Goodbye.